This is a second video about structural battery drone, capable of staying in the air for more than an hour. Please check the first video here. After a few hardware upgrades and some BL-Heli-32 tuning, I decided to try to beat my previous flight time. The most significant change that I made was the ESC. From the big Icon AK32 Pro, I switched to a much smaller and lighter MAMBA F40 128K. The new ESC is about 10 grams lighter, so it's obviously better, right? Well, as soon as I turned the drone on, I noticed a significant increase in the current compared to the bigger Icon ESC. This may significantly decrease the flight time. I'm not sure why there is such a big difference, and I plan to do more research in the future. Another hardware change that I made was a GPS module. In my attempt to minimize weight, I installed a new Flywoo GM10 Nano. It only weighs around 2 grams, and it is the best GPS model I ever had. I got GPS fix extremely quick, and for most of the flight I had around 29 satellites, peaking at 32. This is the biggest amount of satellites I ever had locked. Unfortunately, the Nano module doesn't have a compass, but the good news is they've got a Nano model with a compass available on GOKU website. I recently ordered it, and once it arrives I will change it and let you know how it works. After all the changes, the drone weighs 441 grams, 17 grams lighter than the previous version. I also made changes in BL-Heli-32 settings to try to reduce power consumption. I turned on sine modulation mode, changed motor timing to auto, changed maximum acceleration to 1%, and set current protection to 6 amps. While all these changes supposedly should make motors smoother and thus reduce the power consumption, it is difficult to quantify the effect. I plan to build a simple motor prop ESC test stand to research it in the future. At first, everything looked very promising. The discharge rate was slightly less than in the previous flight, and I was hoping to set a new record, 70 minutes in the air. But as the battery discharged below about 13 volts, the drone started to wobble at higher speeds, or when maneuvering. The wobbling would slowly increase until my drone just fell. I am not sure what exactly happened, but I think it is my BL-Heli-32 current protection settings. Luckily, there is no significant damage. It can be easily repaired by re-gluing the motor mount to the battery. Here is my theory of what happened. A drone requires more or less the same power during its flight to stay in the air. The power is the product of the multiplication of current and the voltage. In my case, the drone consumes about 51 watts. But when motors need to rapidly accelerate, the power may spike much higher for a short period of time. When the battery is at 16 volts, the current stays around 3.2 amps and spikes to 6 amps. It would spike much higher than that for some milliseconds, but my BL-Heli-32 current protection setting caps it at 6. As the battery discharges to 12 volts, the current increases to an average of 4.25 amps, and current spikes increase as well. And with 6 amps limit, motors can't accelerate fast enough, and the drone can't balance itself anymore. I am raising the current protection setting to 12 amps. It should be enough to still stay in the air, even with the battery over-discharged to 2 volts per cell. I will test the new setting and will try to stay in the air for 70 plus minutes in my next videos. I will also post a short video on carbon parts fabrication for my next 8S1P 5000 mAh structural battery drone. I hope to achieve 80 plus minutes of flight time on it. Stay tuned to see how will it all work out.